All right, so we're recording. Welcome to Paideia 301 MUMPS, and we are in class 14. Today we are covering parameter passing, and it's a subject which I'm going to start. We're gonna start diving in right away with examples, and then we're gonna talk about why do we even want to do that. So. We're gonna get started. Uh, Now, of course, I have to remember what my my rules down here. Now, shouldn't this say read? I suppose it should. So enter a number, comma. Calculating the square root of x. And then we're gonna say write x. Whoops, I don't know what I did. Here we go. And this is the square root. No, here we go. All right, so this is a very simple example, and we're gonna try to, we're just gonna run it, and it's not doing any parameter passing right now. So, and of course this is a very stupid line, so I'm gonna go ahead and delete it. Here we go. And so, I'm gonna go ahead and run it. All right, so this is working correctly. Oh, so very nice. All right, so a very simple program that doesn't do much. So let's so now that we figured out that, let's actually try to do we're gonna do something different. So gonna go back to this routine, and instead of, let's presume for the sake of demonstrations that each of these statements is actually very complex, and we actually needed to put have it have us do it separately in a different place of the program. So we actually don't want to uh, put all the logic down here. So what we're gonna do is we're gonna say, let's first deal with the square the square root. Let's do the square root first. So let's do that. So input x, the number to get on which to get the square root. All right, so what we're gonna do now is we are actually passing x over here, and it's gonna do the rest of the routine. But it's gonna get better than this for now. But we're gonna say, all right, we're gonna say right, calculating the the square root of Actually, I even have a better idea. We're going to call this the variable we're entering NUM. So instead of us doing these two statements right there, we just offloaded it into a different kind of logic, a different part of the program. So we're gonna say do sqrt of x, and let's see whether it works now. So here's the brief magic of what's happening is that when we put stuff in parentheses, it becomes a parameter. It becomes a list, a variable that we're passing from our main program down into our subprogram, our subroutine, and it just it cha- when the variable is passed, it could change names, and when it comes back, let's actually make sure that this is all. Gonna say X is still. All right, let's just. Huh? Yeah, you're right. Here you go. Thank you. All right, so let's go ahead and print this. All right, very good. So, excuse me. So let's go ahead and execute it. Of course, I don't have an extra. Let's make this 9 because we don't. Okay, so you'll see here that it actually went. We're going to step through it, but in brief, what it did is that it ran through the program, When it did this, it went down here, took x with it, renamed it, and did the square root. So let's do a step by step through the program. Oops, that's not what I want. So let's do a break of kban parm, and we're gonna set our z-step logic. This is great, but maybe we will get to it after we see this. Okay. All right, here we go. So now it says do square root of x. So that's the next line we're going to execute. So x is 9. Z step into. All right. Now we have not executed this yet. So let's write NUM. NUM does not exist. So all right, now let's write NUM. Now it's 9. Now let's write x. Now notice, x is still defined, so this is somewhat confusing. But x exists by virtue of the fact that it's using the MUMPS rules. We did not new x over here, therefore it's gonna be still defined in our new stack level. So we're gonna do this, and you could see now that you have we defined x on this level, and we're now here, but we did not say new x, and therefore x will still be defined. All right, and this will give us the square root. And we're going to quit. But before we quit, let's make sure we write the number. Okay, so we're still good. All right. Now we're back down. We hit the quit, and we're back down into the first stack level of the program. Let's write NUM. Oops. What happened? Well, we're going to find out. Is x still defined? Write x, because we're on the same level. Okay, so the most important part I want to emphasize that from our tour of this program is the fact that number is not defined when we went down a stack level. What does that tell us about number? What happened to it when it got instantiated as a parameter? Who wants to take a guess? Does it continue? All right, so what happened to number? I don't see anybody responding. What happened to number is number is newed first, then set to the value of the parameter you pass. So this is the part. So this is important to understand. So if you do something in parentheses, it gets newed first before you actually continue with the program. Okay, so far so good. Gonna save this, print it again. Now we actually want to have this kind of passage is known as a procedure, and it's sort of like a transfer of control where the rest of the program executes and then quits. So another kind of subroutine is not a procedure but is a function. And in some programming languages, they don't have procedures at all. They only have functions. So let's see what that's going to look like. So suppose I actually don't want, I actually want to keep the calculation in a separate place inside of the program. So I'm going to go ahead and delete this. Wrong button. Here we go. And we're going to comment this out because we're going to execute it now. And let me see, I want to move this line. So now I'm going to do square root of x. But actually, I don't really want to do that. We're going to say, let me show you the trick. Over here, let's just say new x. New y, set y equal the square root of x. That's not exactly gonna work, but we're gonna show you how it's gonna work now. So over here, what we're gonna say is new sqrt set sqrt equal num raised to 1/2 or 0.5. All right, we're close. We're close. We're almost there. It's gonna. So we need to get. We need to. Let me call this something else so you won't confuse it with the name of the routine of the subroutine. New. Let's just call it SQ. All right, so there's a magic. Remember when I told you that you need to put 2 spaces after a quit when you do a for loop? Here we go. We do 1 space and give quit an argument. We're going to find out what that does shortly. All right. Yeah, this thing should not have compiled, but I don't know why. We'll see. There you go. It thinks it's a. So write $text of en plus 4. Okay. Perm. Okay. That's right. It thinks that square root of x here now is a variable. So we can't do that. What we want to do is, and here's the magical part. Now we put $2 in front of it. Okay. ZZZ link. Let's print it out. Did we ever write the square root? No, we never wrote the. Okay, that's why. All right, it would help if we write it out. So here we're gonna write y, which is the square root. I forgot to put the new line. That's okay. We can run it without the new line. Here you go. The square root is 3. And then x here, it says x is still 9, which is this number down here. So so let's figure out what was different about this. So I showed you that I showed you when you do stuff with a when you do stuff with a do, you essentially execute this line. So there's a sort of a different type of do, and it's called the function invocation do, and it consists of using $2 signs. So when you use $2 signs, you sort of run a function. And the difference between a procedure and a function, and I need to update my documentation here, it still says procedure, is that a function returns a value. How does it return a value? It at the quit, it quits with a value and tells you, okay, this is the value, this is what I produce. You could take it back now. So before going back to this program and examining it in more details, what I'm going to do is I'm going to show you some more examples of functions all over Vista. Yes, Douglas?
I'm not exactly clear, like, why. I know they can't hear me, but...
Yeah, sure. I'll repeat your question, no problem.
Why, when you do the function, you set y equal to the function of square root x.
Yes.
And then you go over there. Why do you set a new variable sq instead of just, like, using num? I don't quite understand that.
Okay. Douglas is asking, and I'm repeating his question so that maybe you can confirm.
I sort of answered it, but go ahead.
Oh, okay. Douglas is asking, okay, when I pass num into the function of square root, why do I use the new variable sq in there? Is that about the right question?
Yeah, but I kind of answered it.
Okay, good. There is no reason for, as is usual in any programming language, it's up to you whether you define extra variables or not. When you define extra variables, you make the program more readable. And so I here created a new variable called sq so that I will hold the result of the square root of number in sq in the second line, which says set sq is number raised to the power of 1/2, and then that gives me the square root of the number, and then I use quit sq to return the square root. All right, makes sense. Okay, good. All right, so a little things of, we're gonna cover this in more detail, but let's just see what this is useful for. So why do we need 2 blank spaces after the quit? It's not something we did in this class. When we did the for loops and you use the quit inside to get out of a for loop, Manohar, what you did is that because the quit in the for loop cannot get you to quit out, it does not get you return values, you have to put 2 spaces after the quit. Do you want me to show you an example? Okay, Tony says yes. All right. So let's do a quick for loop. Now, if you remember, we had the file 3.1, DIC of 3.1. All right. So you get the idea. So, and we said to walk a fileman file, you new I for I equals 0, step 0, set I equal dollar order of up caret DIC 3.1, comma I, quit if, here's the quit if not I. Now see, I'm not gonna put the two spaces here to show you what happens. Right. DIC sub 3.1, comma I, comma 0, comma new line. So GTM gives you an X. By the way, for those of you guys who have not used cache, cache is like the Family Guy weatherman who only says one word to any question. So cache will just tell you syntax. It will not tell you what the hell is going on. GTM usually gives you a lot more verbose error message. And here GTM is telling you, the quit you just supplied me cannot take an argument in this context. And he is really saying inside the for loop, a quit cannot return a value. So you have to put two spaces after the quit, and that's that. You actually get it to run properly. Does that explain it, Manohar? Okay, good. So let me show you some cute things in Vista. I just showed you a little example of how things work, but of how we can do a little function in MUMPS. But I'm going to show you some stuff that's pretty handy in Vista. So Vista has all of these functions, especially lots of them in kernel and FileMan, they're actually constructed for the end user programmer to use. So this is uppercasing. And this is, maybe it's low. Yep, LOW is lowercasing. And of course, some of our favorites are now up caret XLF DT, which gives you the time for right now. So the server thinks it's actually November 27th. Bad server. So it also thinks it's 7:30 in the morning. So we're gonna need to figure out why the server thinks we're so far in the future. And there is a function called FMTE, FM2 external XLF DT, which says I'm going to convert the fileman date to an external date, and we could pass it this stuff over here, and it's going to tell you the date in a human readable format. We're going on and on with that, and you could see we could now nest these two together. Here you go. So we just nested two calls inside of each other. We called the function FMTE. We called the function now, which got executed first, and then its output got fed to the function FMTE. So let's take a quick look at the logic of up caret XLF str. All right, this is the entire line of how Vista does up of XLF str, all of it. You see, he does not define an internal variable to say, you know, I'm gonna, like Douglas was asking, I'm gonna use a temporary variable here until I return it to the user. He just says, Go ahead, translate x with from lowercase to uppercase. And so the big operative value over here is that let's see if I could move this. My cursor is not moving. Oh, here it is. Now it's moving. Notice is that the queue gets an argument, and then the argument is what gets returned to the user. Okay, so a quick note. What so this is a very common error in mumps, and cache sometimes does not catch it properly. Let's see what's gonna happen when we run this. Okay, so we know that this is a problem, let's just say. Okay, so this is the error we're expecting. It says quit does not return to an extrinsic function, argument is not allowed. By the same token, the stuff that you can do cannot be a function. So if you remember, we always did PDI to enter into fileman, right? So can we write $p up caret di? Of course, here. Still, okay, that's not a good example because fileman does not take any parameters. At least not this entry point. I'm trying to show you the opposite case of this one, but that's okay. I think you guys get it. Okay, so this just gives you a little bit of trying to understand how this works, and let's talk about the theory a little bit. Why do we even want to do that? Well, let's see. I'm gonna try to see if I could explain this, use the example here, because rather than write my own example. Okay, so let's take a simple example here. You see you see this, it says here convert a binary binary character 16-bit number into an ASCII number. Doesn't matter what it really means for you guys, don't worry. But what matters is the programmer just designed a function so that they don't have to write it over and over and over again. So one reason to have functions like I have been showing you is that if you do functions like this, you don't have to write them over and over and over again for different for different for different purposes. Down here, they actually don't. Let's actually jump to it. So we'd use. I don't know if I showed you this trick in VPE before. If you type escape R while you're on the up caret, you jump to the routine. So if you remember your math theory class, and this converts this part of the routine converts from one base to another base. So you could convert from base 10 to base 16, for example, or the opposite. And so the whole point of this is that a programmer wrote this once and they will never have to write this again. And so everybody could use it for any conversion that they want. And notice that the quit over here, that gives us a return value. All right, so I am gonna do a very simple. We're gonna actually follow through with this routine, just this part down here. And we're gonna say we're just gonna follow through here because it does return an extrinsic item, and we're gonna figure out what it does. This is a DNS lookup, and that's what your browser does when you type in google.com. It translates it into an IP address, and this is how mumps does it in a certain way. So we're gonna follow through with the logic, and there's some part of it that I'm gonna skip because we don't need to follow it in detail. So here's line 1, and it says new XLF Y and 1, and then it tries Y and I, and then it sets XLF equal to an empty string. And here there's a little bit of a magic going on. He says T equal $get T or A. We did not discuss this form of $get yet, but it's a good time to learn it now. So a 2-argument $get, which is what this is, returns you a value if the variable is undefined. So in this case, effectively, it says if the user does not pass t to us inside of our routine, it means that t is going to be a. All right, moving on. Gonna see it says if the OS contains OpenM and T is A, do, now remember do with two spaces means what? We descend one down. Then it says execute. We did not cover execute yet. All right, execute just runs a line of mumps code. We're gonna talk about it in another class, but for now, that's what it does. So it gives you, it does all of this, and then it sets. You notice that it sets y to equal to something, and then after the do is done, you notice there's a quit with an argument. That means that if you're on cache, all it's gonna do is run down here and go ahead and quit over here. Otherwise, it's going to do the NS logic. And the namespace logic NS is actually down here, and we're not gonna actually go into it. So, I believe what this does, this is a for loop, and it says go through step 1 to xlf an count. So you might be asking, okay, how the hell did mumps give subscripts to xlf down here? Well, this is actually going to be the next topic we're going to cover, which is, you see this dot in front of the parameter. This gives it a different meaning than the ones we have been doing so far, and I'll explain it in a moment. But let's just say that it essentially makes it possible to give subscripts to the variable, and what comes back with subscripts. Because when you quit with something, you could only return a single value, but this is another way to return a value. So we're going to talk about it in a moment. Step 1 to xlf an count, and my guess is that AN count probably means the number. They actually have a number of replies that the server gave us, and so we set if $data of I, it's AN underscore I underscore data. You see that, and Y equal to XLF, same thing, the same variable, and add a comma. So what's it doing here is that it's saying if you find, if the server says we have a count of data, and loop through the data, which is an I, and append it all to Y. So basically Y will keep getting appended, because you could see, how do we know we're doing an append? Is that it says Y is equal Y, and then we're appending data. So every time we go through the loop, we're adding more data onto Y. And this is a sneaky little line. What does that one do? Anybody? It should be an easier line. It is extracting, but why is it extracting to -1 of Y? Oh, exactly. Rob got it. It's there to remove the trailing comma. So there's an extra comma at the end. So actually, let's go ahead and run this routine now. So in order for this to work correctly, we actually have to configure the kernel to have the correct DNS server in it. So I'm going to do that first. Kernel system parameters, DNS IP. There's only one domain, and I don't know whether this is correct or not, but we're going to find out. I'm not going to take a chance. I'm just going to set it to an IP that I always know. This is Google's DNS IP, so that always works. So now write $$ address, address, XLF NSLK www.google.com. Okay. We should ignore these. These are all compilation errors from GTM. So let's run it again. Here you go. You see now, Google has all of these IP addresses. So here's another example of it passing another parameter. I don't know. Oops, what's going on? Oh, here. So let's say I actually want to get mail.google.com, but I don't want their IP. I don't want their internet address. I want the mail address. So you're going to tell it I want the MX records. Now, if you're not a DNS geek, you wouldn't know what MX records are, but trust me, they exist. All right. Here it tells me that the VISTA does not see that the mail.google.com has any MX records. Let's just tell it internet addresses, and it's going to give us these two. Now, we can ask it for the IP version 6 address. Now, let's see if that works. I have no idea whether Vista supports it or not. Okay, that's weird. I think that should not work like that. It should try to ask it for the IP version 6 addresses, but it did not do that. Okay, I suppose that's enough exploration with DNS from Vista. So let's let's go. Let's talk about let's talk about the theory now. Uh yeah, I know. Dot e. Uh, okay, bam, bam. Okay. An MX record is a mail the record that you use in mailing an email. So emails go through a different, basically a sort of a slightly different infrastructure than your regular internet. Okay, so let's talk about a bit about the nomenclature. So we call this an extrinsic function. And it's important because an extrinsic function is different than an intrinsic function. So, all right, so an intrinsic function is like $extract. So, now, so basically a single dollar means intrinsic function. And intrinsic means part of the MUMPS language, essentially. $, means extrinsic function. And extrinsic means it's user defined. And so the important thing is that the other piece of terminology that's important is that anything you invoke with a do is a procedure, has no return value. Anything you invoke with a $, is a function, which means has a return value. And we're going to also say that $, can only return a scalar value. What's a scalar value? Scalar. It's essentially think of it as one string. So it cannot return an array with x sub 1, x sub 2, etc. So that's important. We're gonna talk about how you return an array from a function in a moment, but right now it's important to know that $, just gives you back a single value. All right, let's see what else we covered. We said that the difference between do and $$ procedure slash function is that a equate with a value makes it a procedure. All right. So I do need to mention, but due to its yes, sorry, you are right. Equate with a value makes it a function. I'm sorry. Thank you, Rob. I did make a mistake. You're right. So I'm trying to think what else that I need to give you the terminology for. Yes, okay. There is one thing I didn't discuss the terminology for, and um, passing parameters without a dot in front of them is called passing by value. With a dot, which we haven't covered yet, we're going to cover it in a moment, it's called pass by reference. Now, if you come from almost every programming language I know, maybe except JavaScript, to be honest, has a distinction of passing by value and passing by reference. And so we're going to cover passing by reference right now. Sorry, that's the wrong routine. Kban parm. Here we go. So let's annotate this. How did I exit from there now? I'm sorry, I don't follow you. From VPE, I pressed 2 escapes. Is that what you're asking? Manohar? Uh-huh. Sometime it's now working. Huh? 2 escapes. Okay, 2 escapes gets me out of a routine. Now I wrote a routine kban pass that did not exist. It's empty. You see it's empty? So I pressed 2 escapes. The routine was not saved. Is that what you're asking, Manohar? Oh yeah. Okay. Uh Yeah, I believe the key is that you don't want to type anything before you press 2 escapes. You just have to type 2 escapes and it's going to get you out. Okay, so let's illustrate passage by value. So a passage by reference. So reference, and we're gonna call this, okay, return public function illustrate passage by reference. So I'm trying to see if I could figure out I could do something useful here, but I can't think of one right off right now. No, I do have an idea. I could read the data in a FileMan file and put it into return. So let me do that. Okay, so again, same idea. Was the title file 3.1? Remember it was. Hold on. You're Linda's looking at me just saying, you're asking me. I'm gonna just take a look, make sure that I have title file is indeed 3.1. Yep, it is. Okay. So back to our example. So in here, let's just call, instead of calling this ref, I'm gonna call it titles. Input/output return pass by reference. And so what I'm gonna do here is I'm gonna say, let me see. Okay, so I'm gonna say new I for I equal $order through DIC of 3.1 comma I. Actually, for I equals 0:0 set I equal. I always make that mistake. All right, quit if not I. Same thing that we did before, all the same, nothing changed. Now, what we're gonna do after this is we're gonna say set return equal to return sub I, actually equal to DIC sub 3.1 comma I comma 0. And here we're gonna quit. So empty line. So let's have a try at it. And instead of running through this old program, what I'm gonna do, let me do this. Escape delete, here we go. And I'm gonna make an en2 entry point for showing title. So we're not gonna execute the other code that we ran. And we're gonna say do title, right? It's titles plural slash dot x. So we're gonna say, actually before we do dot x, we're gonna say new x, do titles of x, and then 0 x just for debugging. And it's my tradition. Oops, it's my tradition to just put a debug around 0, so I would recognize it later. So let's give it a try right now. No, do zprint first, zprint. And then do en2 upgrade kban parm. Okay, so what happened here is that when I tried to pass titles down here, now remember I did not put a dot next to it here, so it was trying to pass it by value. So when it tries to pass it by value, it's actually going to copy the value here, and like if you remember here, it's going to copy it and put it in this variable. Did it do that here? It copied it, but when I tried to copy it, it said, uh-oh, no value is there, so it's not going to work. So with that, we're gonna actually give it a different try. What we're gonna do is we're gonna say down here, we're gonna say dot x. Now we're passing it by reference. Now notice that the dot goes on the invocation, it does not go on the receiver end. This is a bit confusing. So only the invoker knows whether it's passing it by reference. The caller needs to. This is a sort of a misfeature in the MUMPS language, which is not that great. But when you're reading the routine, there's no way until you actually read all the code to figure out whether it's actually supposed to be called by reference or by value. So z go to z link. Z print it, and here you go. That's more like it. So let's figure out what happened. Over here, when we ran this routine, it said, okay, new x, which means that x is going to be a variable defined at this level, then executes titles.x. Now, as before, this time it's not passing by value, it's just changing the name of x here. So return is actually the same as x. And here's the other important part. When you pass by value, remember when you passed it number here, when you passed number here got newed. Here, when you pass by reference, it does not get newed when it goes here. And we've illustrated how this loop works before. So all we did is that we set return sub I equal to the value of the fileman entry. And then when we print it using zwrite, we actually get the data back because return, after this is done executing, its name goes back to being just x. Now, from the looks of Linda and Douglas, I see you guys are confused. You pass x empty. So Linda's question was, how do you know what x is to pass it into the first place? No, you pass an empty variable. So the variable does not have to be empty, in fact, actually. It could contain other content, but you could go ahead, delete it, or you could leave it. It's up to you. Linda's still slightly confused. Little bit. Okay. Okay, guys. I can't see your faces, so I need you to type out what you're thinking. Manohar says with a parameter with a dot means you're passing it as a reference, and the answer is yes. That's exactly right. Well, I can't believe that I explained it so clearly that you guys don't have any questions. It's more likely to be the opposite. Okay, Manoj is typing something. I'll wait for him. When we quit the for reference, it will pass the array back. It does. That is not exactly what happens. Let me follow this through again. So all that's happening internally in mumps. Let's backtrack a bit. Manoj, do you know C? Have you ever programmed in C before? Okay, good. So in C, there is not you really there's no such thing as passing by reference. You either pass the actual value, like we did down in square root, or you pass a pointer. Essentially, in mumps, it is passing a pointer, but that you're not seeing that. So it's saying here it's saying x represents a variable in memory, and what just happened is that instead of x pointing to a place, instead of the place in memory having the name excuse me, let me see, instead of the pointer being assigned the name x, the pointer is assigned the name return, but it still points to the same place in memory. That means that every time you manipulate return, you are manipulating x. And therefore, you are not really passing. The quit here does not have any effect on the passage of the variable. Okay, good, good. All right. So, okay, Tony has a question. Okay, can you go through it again? Tony, how about me? I'll do other examples. I'll show you how it's used, and then we're gonna talk about how it works again. We're gonna talk about how it's used first. Okay, so um, the RPC broker in Vista has a parameter format that it always does, and if you go down, it always uses the first variable as the return variable. And we're gonna just run an example. So remote procedure, and let's try ORW new person, and that just gives you the list of new persons that are available in Vista. So what you could to invoke it, the way it works is that you do new person upcut ORWU. Actually, let's just write the actual tag so that we know what it looks like. So it's actually new person upcaret ORWU. And you could see that it takes a lot of parameters, but most of them are actually optional. So we have to pass the first. We actually only need to pass one for that matter, but you could pass the second and the third. I'm gonna show you how that works. So let me do zwrite RTN for return. It's empty, okay? So we know that doesn't exist. So if I do new person upcat ORW of RTN, Don't forget put a dot. Okay. Now we know it actually we have to pass the second variable because it tells you that the OR from variable is required. So I'm gonna tell it let's start from the letter C, and OR direction means going forward or backward. So we're gonna do 1, for example. Okay. So then you get a list of people under return. But notice how this worked. Return was empty when we started, and then it got execute when we started running this routine, it got renamed to ORY, and it went through the routine, renamed this, and kept looping through it, and returned us all the people who met the criteria. And when we exited, ORY represents the same location in memory as RTN, and therefore the whatever it put in RTY, an ORY also was an RTN. And so when we get back, we find our data in RTN. Let's do a quick walkthrough to that actual routine so we could actually see what it looks like. ZV. And it's ORW. By the way, you guys need to read this. This is essentially the Rosetta Stone to CPRS. It tells you what keys you need to have in order to be considered a doctor, a nurse, a clerk, and so on. So where is the new person? Oh, here we go. So this actually got moved to another place. So let's take a look at it. Escape R. And here you go. All right, there's a lot of logic here. And I'm almost regretting now that I showed you this because it's way too complex. Now, okay, guys, forget about it. It's too much. I'm gonna forget about it. It's not worth looking at. Okay. Um, so the lesson is from all of this is that essentially this is what the remote procedure broker uses to get its data. You just, in order to debug remote procedures in CPRS, you just find out the name of the remote procedure. So well, there's nothing with that name. Isn't that funny? Okay, here we go. That's a good one. So let's say you want to figure out how does the problem list work. So you actually could find this from CPRS from your help menu. If you have the programmer key, you could see what procedures it calls, and then you could see this gets you the problem list for each patient, and it's the tag prob L at routine ORQQPL3. So if you write $text of prob L upcard ORQQPL3, you get the list of patient problems. And it looks like you need to at least pass the DFN, which is the patient number. Otherwise, I don't know what the context is in this case. So going back, and I'm gonna try to explain it better for Tony. Let's go back to our routine. actually, we don't need to do this. Zprint, kban, parm. Okay. Zprint, zbreak, en2 upgrade kban, parm. Do en2 upgrade. All right. It went down into it directly. Oh yeah, okay. That's fine. Let's run it again. All right, because it's not showing us what the first line is. I'm just gonna write it out. So this is where we are now. It has not executed yet, so we don't know what X is yet. But X should be undefined right now. So it's gonna run down to titles. So we're gonna do titles. All right. Now this thing will let's look at return. Just tell you I have nothing up my sleeve. All right. And if we just do zero x, sometimes. Oh, here this is just a feature of GTM. When you see a star when you do a zeroite. Does that just work? No, it does not. I didn't think so. But when you see a star in your zeroite, you notice that X and return mean the same thing. They point to the same location in memory. But this is something that you just see in GTM. So let's look at our line again. And return. This line has not executed, so if we zeroite return, it should be empty, and it is empty. Now we step into once. Now with this line executed, let's find return. Okay, that's good. Notice what happened here. X is also defined now, because X represents the same value in memory as return. Okay, now we're back here. We're back to the main program, and the main program now has X, but return should not be defined anymore. Let's find return. Nope, return is gone because return was only used internally inside that routine. And that's it. Tony, hope that helps. Sort of. Okay, I'm gonna leave it to, I'm probably gonna leave it for, it sounds good. I'm gonna probably, I'm having difficulty explaining it to you guys, so I'm gonna have to rely on you to explain it to each other, because I don't exactly know how to explain it better, but I think you guys, once you get it, it should be pretty easy. All right. So your homework. We're gonna take a look at the homework. Okay, and I want you to change your pumpkin routine so it will do two things. So I need to have an example. I can't remember the example. I could use yours, but I did not copy yours, Linda, to the server, so I don't have it. Let's take a look at Tony's routine. Okay. So Tony, this is your homework, and you got the rest of you guys. You're gonna have similar homeworks. You're gonna have to figure out how to make the homework fit your routine. So get weight gets an array. So I want you to instead instead of just doing get weight and using a global variable called weight down here to keep everything, I want you to new a variable that contains the weights, and use in get weight use a return variable, use a return type parameter in order to get the weights back. And by the same token, what I want you to do is, when you output your data, I want you to send it to your routine and send an array by output, and also down here. So, and do wait array and output, and the end. Let's see what you do down at the end. I think you just write bye or boo boo. So, uh, so the your end objective, everybody, is you are not allowed to have variables that leak from function to function. Means that all the variables that you do have to be contained within each block. Therefore, you see this weight down here, this variable weight, it cannot leak. It has to be in a parameter list down here. Does this homework make sense? Did I explain it properly? Let's see, what does Linda think? Let's try Manoj, I believe's homework, and let's take a look at how we were gonna do it for him, because his homework is simpler. So he does a menu here. So here's a read. So again, you notice that con1, he puts the arrays. His array is z over here, and then he just uses z. I don't believe he actually leaks that many variables between routines, because most of the logic is done down here. But there's no separate section for printing, so that's why he doesn't have that problem. So Manoj, your homework is that you have to have separate sections for reading and for doing and for printing, where you're gonna have to pass variables between them. Okay, let's take a look at another homework, and that's Tom Heller's homework. Let's see if he. So here's way and here's list. All right, so this this is a perfect example. Now he puts his array in the letter y, in the variable y. So, and then he goes down here in the using the letter and goes through y. So he has to pass in the ways, pass in ways so that they could put them in y's, and send y down here to the list so that they could get printed. And here's a little idea. You guys could, where's the pumpkin weight reading? It's down here. That's okay. I was thinking you guys could abstract the pumpkin weight reading into a different function as well. But that's okay. You could just leave it in there. All right. So that's your homework. So let me write it down. Homework. Refactor your pumpkin routine so that no variable is transferred between different sections except if you choose to do so, except if you pass it in as a parameter. Okay. And before we break, I showed you some APIs for Vista today, and I just want to show you where all those APIs are. And so, um, let me see. So I'm gonna paste this in Skype. These are the API. These are all the APIs for FileMan, and for the kernel, the API list is over here. And you're gonna find so many APIs. You know, you're gonna be in API heaven essentially. Okay, that's it for today's class, and I will hope to see you next week. Please don't hesitate to contact me if you have any questions about how reference variables and how variables work. Okay, Linda says, I assume what APIs are. APIs are essentially programs in Vista that we invoke so that they do utility stuff for us. I showed you some stuff like how to uppercase a routine, for example. And you're gonna find a lot of them over there. Okay, that's it. Thank you all.